So in 10.4 we learned about inscribed angles, intercepted arcs, and then we learned a couple of applications dealing with that. So the inscribed angle, like angle X, would equal what in number 1? What? 38, half of 76, right? So 76 is the intercepted arc, and the angle would equal half the intercepted arc, in this case 38 degrees. Okay, in 2, it's the other way around. Now you've got the angle, you want the intercepted arc. How do I get from one to the other? Good. So this time I'm going to double it. So 28 times 2, which gives you? Good. Questions on either of those? Okay, and then 3, we've got, what's happening here? What's the easiest way to get it? What's true about the 44 degrees and the X? They're angles that are congruent because they both intercept the same arc, right? So this arc is intercepted by both angles, the 44 and the X, which means they are congruent. So I could go long ways about it, double the 44, get to the arc is 88, and then cut it back in half to get the X. Or just identify that they both intercept the same arc, and you would know that they are congruent, so X is 44. The other 2 things that were in this section were, let's see if it was just 2, off the top of my head I know it's 2. An inscribed quadrilateral. What do we know about the inscribed quadrilateral? Good. Opposite angles are supplementary. So if it was something like this, angle 1 and angle 3 would be 180, and angle 2 and angle 4 would be 180. And then we also learned that if I've got a tangent, that the arc formed by a chord and a tangent would be twice the length, or twice the measure of the angle, or angle is half the arc. Oh, and then I knew there was another one. And then the right angle thing, right? So if I've got a circle and I've got an angle whose endpoints are the endpoint of the radius, of the diameter, then what do I know about that angle? It's a right angle, okay? Again, you could go long ways around. I know that half the circle is 180, and that's an inscribed angle, so it would be half of it. Or you could just remember that theorem. Okay, so all right. So this is my quadrilateral, right? Inscribed in a polygon. So 4y plus 100 equals 180. 4y would equal 80, and y would equal 20. And then the other way, 2x plus 72 would equal 180. 2x would equal 108, and x would equal 54. Questions on those? Okay. So in 10.5, we're going to learn, it says apply other angle relationships in circles. So now we're going to learn if it's not an inscribed angle or if it's central angle, what are other ways that we can find the measures of angles inside a circle. So this is the first one. If a tangent and a chord intersect, and this is what we talked about actually yesterday. It's just that the theorem's not mentioned until this this section. If a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So again, we talked about this yesterday, but it's not in your book until this section. So it is Theorem 10.11, which is the 11th theorem in chapter 10, but I don't need you to know the number, I need to know what it says. So if I gave you that arc AB was 110 degrees, what would angle 1 be? Half of that, 55 degrees, right? Okay, and then what would the arc BCA be? 250, right? Because it would do 360 minus the 110, which then makes angle 2 125. And then remember we talked about yesterday that the rules of lines still apply. So 125 plus 55 give you 180 because that's still a tangent line. So they would have to sum to 180. Questions on that one? Theorem 10.12 is the angles inside a circle. So I tend to call these floating angles. I don't think that that's like an actual term. I kind of made it up just so we can talk about it. But these are not inscribed, nor are they central angles. So the angles that are somewhere floating around inside the circle that are formed by two chords. You can find the measure of them by adding up the two arcs they intercept, or the arc it intercepts, plus the arc its vertical angle intercepts, and then divide by 2, or multiply by 1/2. So if the arc is not, or if the vertex is not at the center, or on the circle, so central angle or inscribed, then you would use something like this. So let's say this is 80 degrees, and this is 40 degrees. Angle 1 would be 1/2 the sum of those two. So 40 plus 80. Or 1/2, 120, which is 60 degrees.
So it's going to have like a pattern?
What do you mean?
Like you add 20 for that one? To each like angle?
Well, because you did half and half. It just happens that it's 40 and 80. It could be 100 and it could be 20. You just want to add them and divide by 2. And then these are still vertical angles, and that's why they'd be the same. And then if I had, this was 120, can I find angle 2? How? I can add 80, 120, and 40. So that was 120 plus 120, which is 240. Subtract it from 360. And I get 120. So assuming that they are the same, it's saying they're both 120. I just made up numbers that have to be the same. Okay? To find angle 2, I would do 120 plus 120. And then divide it by 2 or multiply by 1/2. Alexis.
Wait, how are those congruent marks to put in there?
Yep, so vertical angles still apply inside this. So this would still be congruent to this as well. So,
But I thought you said that
it is.
then how would that be congruent to the other one?
This angle in here would be 60.
I thought it wouldn't be 20 if that wasn't.
No, it's not a central angle. So they're no longer on the center. That's the difference. Does that make sense? Okay, and then Theorem 1013 is the angles outside a circle. And there's 3 different cases with these. So if a tangent and a secant meet outside a circle, or 2 tangents meet outside a circle, or 2 secants meet outside a circle, then you find the measure of the angle by doing the large arc minus the small arc divided by 2. So in plain English, it's big arc minus little arc divided by 2. Oh, those are degrees. Yeah. So the one on the left would be 2 secants. So to find angle 1, I would find the measure of this arc, subtract from it the measure of this arc, and then divide by 2. These are 2 tangents. Same process. I would do big arc minus little arc divided by 2. And then the last kind is a secant and a tangent. Same big arc minus little arc divided by 2. So the actual formula stays the same for all 3. It's just what they look like that would appear to be different.